In this video, we're going to take a look at time value of money and how interest rates work. Probably one of my favorite subjects, and let's consider why this is important. Life decisions we face all the time. Would you rather get a 15-year mortgage and pay it off in 15 years? Would you rather get a 30-year mortgage and pay it off in 30 years? Get a 30-year mortgage and pay it off in 15 years? Would you rather take out a car loan or a home equity line of credit to buy a car? Would you rather pay off a credit card, student loan, or home mortgage early? If you could only pick one, which would you pick? Should you invest in municipal bonds? Well, I will tell you something. I grew up in a low-income household. At one point, my father worked in Radio Shack and retail. At one point, my mother worked at the local McDonald's. My mother, also a tall redhead. Most of the kids in my grade school knew who she was. And let's just say I was a very popular kid in grade school because they knew my mom worked at McDonald's and made the big ice cream cones and probably knew Ronald McDonald because that's what we thought in second grade. But nonetheless, I grew up in a low-income household, and it is something that I am now very grateful for because I was amazed with this concept that I could put a little bit of money in the bank and I would earn interest on it, and the bank would pay me for holding my money. And as a little kid who had assets of maybe $20 to my name at the time, getting a bank statement and seeing I earned 12 cents was absolutely magical to me. And it taught me a very valuable life lesson, which is be a creditor, not a debtor. You have a choice in life. You will either be one who is borrowing money or one who is lending money. And I will tell you that life is much easier when you're one who's lending money and earning interest on that money instead of borrowing money and paying interest on that money. So let's consider how net present value works. If I offered you $1 today or $1 in a year, which would you rather have? You'd probably rather have the dollar today, right? Okay, well, let me try to make it a little more enticing. What if I offered you $1 today or $1.05 in a year? This is a question I like to ask in the classroom. When I ask the first question, everybody says $1 today. When I ask the second question, most people will say $1 today, and a couple people will say $1.05 in a year. But then we say, okay, let's make it a bit more lucrative. Let's say $1 today or $2 in a year. Then it's about 50-50. Usually about half people say, I'd rather have the dollar today, and the other half say, I'll take $2 in a year. Okay, let's say $1 today or $100 in a year. And this is interesting. Usually about 90% of the audience will say $100 in a year, but there's still a couple holdouts who would rather have that dollar today. And whatever of these you choose, that's your discount rate. Effectively, that is the amount of money you would expect to earn if you withheld that dollar for a year. Or in other words, if I gave you the dollar and then you immediately lent it out and received it back in a year, that discount rate is your payment for waiting to get that dollar. And so if you say I'd rather have $1.05 in a year than $1 today, then your discount rate is 5%. It's funny, if you say $2, then your discount rate's 100%. If you say $100, it's huge. Let's just say it's huge. But nonetheless, that's your discount rate. So what we can compute then is we can turn this formula around a little bit. We can say, okay, let's say I'm going to give you $200 in a year. What is that worth today? Okay. So for that, what we'll do is we'll take that future value of $200 and divide by 1 plus the discount rate. And it says $200 in a year is worth this to you today. Just as we could say with our argument above, we could turn that around a little bit and say $1.05 in a year is worth $1 today. And that's the time value of money. That's the entire concept of the time value of money. And it is a very important concept because it's something that underlines basically everything in finance. So for example, if we would get a $200 payment 1 year from now, and we divide that by our discount rate, 1 plus the discount rate of 0.5, then $200 in a year is worth $190.48 to us today. Or, once again, we can turn that around and say if I lend you $190.48 today at a 5% discount rate, then in 1 year you need to pay me back $200. The $190.48 of principal, and then about $9.52 of interest is what that would work out to be. Now, we can try this on a calculator. Very straightforward. You see, if you just put in, you can see the formula that I used here. $200 or 200 divided by 1.05 is 190 roughly 0.48. So that's the present value of that future cash flow of $200. So I've used a few terms here that are fundamental to time value of money. And let me just stop for a moment and define them here so that we can have a consistent meaning of what these things are. Present value, what's the value today of $1 tomorrow? And there's some Excel functions and abbreviations that we typically use that we'll explore a little bit later in this video. PV, NPV, and XNPV. So, present value, I'm going to receive $200 in the future, and this is what that is worth to me today. Future value. Now, very similar concept, but kind of just in reverse. We're saying, what's the value tomorrow of $1 today? So I have $1 today, and if I lend that out at maybe 5% interest, what will I have in the future? Now, payment is a related concept I'm going to explore in a video right after this, where we talk about mortgages. Payment is saying, okay, I'm taking out a loan and I'm going to pay it back with regular payments. What will the amount of those payments be? And what's neat is if we can look at these formulas, we can kind of mix them together a little bit and we can come up with some really interesting financial analysis. With future value, we're saying I have this quantity of money today. Let's apply the discount rate, and this is what it's worth in a year or whatever the period is. The only difference between present value and future value is, do we multiply or divide? So if we're looking at the present value of a future cash flow, we're going to divide by 1 plus the discount rate, or 1.05 in our example. If we're looking at the future value of a current cash flow, then we're going to multiply. So if I have 200 now and I lend it out, then we're going to multiply that 200 by 1.05, and that's the payment that we will receive in the future for lending it out. So two very similar concepts, only differences, are you dividing or are you multiplying? So what about compound interest? What about that idea of earning interest on interest? Well, that's actually pretty straightforward to calculate as well. We use the same formula, but down here in the denominator, we take the quantity of 1 plus the discount rate, 1.05 in our case, and we raise it to the power of the number of periods. That's the definition of compound interest. You are receiving interest, reinvesting it, and then you are earning interest on interest. A lot of times you'll see banks advertise a rate and a yield, and the difference is compound interest. The rate is the rate that you're paying, but the yield accounts for that compound interest. And one thing that is important in that is, how frequently do we compound? A lot of times we'll assume we'll compound once a year. We could compound once monthly. We could compound daily, or we could even compound continuously, which is, it's interesting. It's a way that that rate and yield can be gamed a little bit in some cases. So effectively, if your period of investment is 1 year and the rate is 1 year and it compounds in 1 year, then the rate and the yield are the same, because you don't have compound interest. It compounds yearly, right? So the rate and the yield are the same because you're receiving that interest payment at the end of the cycle and you're not earning interest on it. On the other hand, if you compound daily, that means every day you're getting paid a little bit of interest, and then the next day you're earning interest on that interest. And then you'll see the rate and the yield diverge a bit more. In the late 70s, when there was high inflation, banks were having a hard time getting deposits because of usury laws. They can't charge interest greater than 25%. And at that time, inflation and interest rates were approaching that. So to try to entice more savings, what they would do is they would increase the compound period. So the rate they were paying was 25%, but the effective yield was actually higher because you were getting your interest and then earning interest on like a continuous basis instead of waiting until the end of the period. So that's the difference between rate and yield. So Net present value is looking at the present value of a series of future cash flows. These cash flows could be positive cash flows if they're revenues, or negative cash flows if they're expenses. But what a net present value will do is you can give it a series of flows. They can be variable amounts, they can be variable times, and it basically takes this discount rate and says, okay, here is the present value of those flows. Or we could say the future value if we want. Either way, it's depending on, do we want to know what it is in today's money or in future money? That's going to determine that. What's good is that Excel has some really handy computations for us in PV, which assumes regular periods, or XNPV, which assumes variable periods. You can also use a financial calculator. Over here on the right of this slide is the Texas Instruments BA2 Plus. There's a much newer version of this. What you're looking at here is a version that was available in the mid-90s. The reason I picked this one is it's the one I bought when I took finance in undergrad, and I credit that calculator with at least a 1-letter grade boost in that class. That calculator was absolutely fundamental to getting a good grade in that class. I kept that same calculator through graduate school, and it helped me through grad school. And I had it up until very recently. I got lost in a move, unfortunately, but that was probably one of the best $35 I ever spent back in '95. So we can do this math with a calculator. We can also do it in Excel. Let's say I have a future value or a payment that's coming to me in a year, and that future value is $200. My discount rate is 5%. I can simply say equals NPV, and then I pass in my rate. And in this case, I just have one payment coming, so a future value of 200, and it will assume one period. And guess what? That number looks kind of familiar, doesn't it? That's the same $190.48 that we computed earlier. Now, the neat thing is it's very easy to expand this concept. We could say we're receiving payments over a period of time. Maybe we're renting something out like an apartment or an Airbnb. Or maybe we have a side hustle where we're making money off social media or something like that, and we're forecasting that this is going to be our payment over a series of years. So we can say, okay, what are all of those future payments worth today if I were to apply the discount rate? Neat thing about net present value in Excel is we can use either the same numbers like this, or we can vary the numbers, and we can even get a little more sophisticated and say, okay, I'm going to figure out the net present value, but there is an initial outlay and I want to subtract that. So maybe if I'm a YouTuber, I need to get my studio microphone and background and computer and all that setup stuff, and I want to subtract that from my net present value. Let's see how we can do this. Well, I've expanded our spreadsheet a little bit. I have our discount rate of 5%, and now I have 10 payments of $100. So that's going to total $1,000 in payments, but we need to discount it because we know we would rather have $1 today than $1 tomorrow. So we have to discount it to say $1 tomorrow is worth less to me than $1 today. Real easy formula in PV again. And this time we start with rate. And then instead of one value, we just grab each of these values. And we see that 10 payments of $100 each, total of $1,000, over 10 periods, we'll assume those are years, gives us a net present value of $772.17. Now, what's neat about this is that this one's a fairly straightforward formula. So we'd have that first 100 divided by 1.05. Then the second 100 would be divided by 1.05 squared. The third 100 would be divided by 1.05 cubed, and so on and so forth, because we know that's how compound interest works. But what makes this neat is that we can vary these payments, and we can say, well, you know what? So I have my channel, and I'm going to start building up some regular clientele. I'm going to look at ways to optimize earnings, and I suspect these numbers are going to grow over time. And yeah, so we can keep going with this, say 400 in year 7. We can work out some of these projections, and it gives us a neat kind of what if scenario. And there we go. We see with irregular payments, we now have a present value of $2,095.03. But maybe we have an initial outlay as well for any equipment that we needed to buy. Maybe that was $1,000. Then we'll say, you know, we'll kind of give it like a projected profitability, if you want, which is where we'd say, okay, let's take the present value of those future cash flows and let's subtract from that the initial outlay, and that gives us $1,095.03 in this case. But so far we have assumed that these payments are all going to happen at the end of the period and that it's regular periods. It gets really confusing if these payments happen randomly, but guess what? There's a formula for us. Let's take a look at XNPV. I've updated my spreadsheet now, and I still have the random payments, but instead of having periods across the top, I now have dates. And you notice I just randomized some dates from 2025 to 2029 over several different months. I could even switch the days. Now, I will say this is US date format, which is admittedly confusing. Month, day, year, so January 1, March 1, January 1, June 1, September 1, yeah, like so. Now, for the present value, we simply need to change this from NPV to XNPV. And now, once again, we can look at rate, which I have in this F, and then values. I'll highlight this. And then dates, and naturally the dates need to match the values. We couldn't have more dates than values or less dates than values or anything like that. And we see now with this more random date format, we have a present value of $2,565.21 minus our initial outlay of $1,000, gives us the projected value, basically worth of this project, if you will, of $1,565.21 in current dollars. And here we go with a look at XNPV in a few different simulations. Now that we have this understanding of the fundamentals of time value of money, we're ready for our next concept, which I'll explore in the next video, which is, would you rather get a 15-year mortgage and pay it off in 15 years, a 30-year mortgage and pay it off in 30 years, or a 30-year mortgage and pay it at the higher payment of the 15-year mortgage? And what's the difference in that? How much longer would it take to get paid off, or what are the idiosyncrasies of that? So stay tuned. We'll see you in that video. Thank you.